Hi everyone. So this is lesson 2-4 of Algebra 1. So today we're going to be talking about writing linear equations in slope-intercept form. So our goals today is one, to be able to determine the slope of a line given a graph or 2 points. Some of this we've already done. And then the second is to write a linear equation given only 2 points. Our essential question today is, how can I write a linear equation if I only have 1 point and the slope of the line? So this is kind of a challenging task for some people, so that's what we're going to kind of focus on today. So just a quick review here. We talk about the slope, right? We're talking about how much a line goes up and down versus how much a line goes side to side. So we talk about that as steepness. We can talk about that as a rate of change. And slope is generally the term we use for that. The slope is just the ratio of how much a line rises to how much a line runs. The rise is the up and down, and the run is the left and right. So we talk about that slope as being that ratio of rise to run. And here's an equation or a formula for calculating slope. I'm not a huge fan of using formulas and memorizing formulas. I think it's a little bit easier if you can understand what slope is and kind of just sort of conceptually work it. But there's a formula for it. It's just the difference in the y values divided by the difference in the x values. We typically write slope as a fraction, right? And we always simplify. Okay, so we always write that fraction in its most simplified or most reduced form. Generally, we don't write slope as a decimal, and generally we don't write slope as a mixed number. However, if you have a slope that's an integer, we would just typically write that as an integer. We wouldn't write that as, like, for example, 4 over 1. We would just write that as 4. So just kind of work through these quickly. How to find the slope of this line? Well, there's a couple ways that I can do it, but the easy way is just to simply look for some points. I want to look for some points that cross through here. And so, for example, if I look at this point right here, right, it looks like the line passes right through that coordinate there at 0, 4. And then it also looks like it passes through this point right here at 3, 8. Right, 3, 8. And so I could write out those points and plug them into the slope formula. But I can also just see, well, how much does it rise? It rises 1, 2, 3, 4. 1, 2, 3, 4. So from this point to this point, it rises 4, positive 4. And then it goes left or right. It does a run of 3. 1, 2, 3. Okay, so I'd write that slope. I would say that slope is 4 over 3. And I would just leave it in that form. So calculate the slope between these 2 points. Again, you can use the slope formula, but I find an easier way to do this, or easier for me anyway, is to just look at the y values. And from here it goes from -3 to +4. So if I visualize that on a graph, it's going from -3 up to +4. That's a change of 7. It's going up 7. And then from -2 to 5, so I'm thinking left to right, from -2 over to 5, it's also going up +7. And so I would simplify this. 7 divided by 7 is just simply 1, and so I'd write that like that. Okay, that's a slope of 1. Every time x changes by 1, y changes by 1. If I wanted to plug this into the slope formula, I could say, well, m is equal to y2 minus y1, and I would say, well, this is x2. This is the x for the second point. This is the y for the second point. This is the x for the first point. And this is the y for the first point. And so I'd say y2 minus y1. So 4 minus -3 over, and then 5 is my second x value, minus -2. And I gotta watch the minus minus here, so that becomes 4 plus 3, which is 7, and 5 plus 2, which is also 7. So you see we get the same result if we use that slope formula, but I find it actually a little more challenging because now I've got to go through and like do a number of calculations, and I have to make sure I get the negative negative right, and I have to make sure, you know, that I put them in the right order and that sort of stuff. For me, it's just simpler if I just visualize I'm going from -3 to +4. That's a change of 7. So I can just kind of calculate that in my head. Now the other thing to note here is, how do you know which one's the first point and which one's the second point? And the answer is you don't. So these are interchangeable. I could have just as easily called this x2 and y2 and this one x1 and y1. And I would have plugged those in and it would have been exactly the same. I would have ended up with -7 over -7, but when I simplify that, I still get +1. Okay, so pick a method that works best for you, right? There's lots of different ways of doing it. You could also graph these, you know, and count them, and but I think for me anyway, the simplest way is just to kind of mentally calculate from -3 to 4, it changes by +7, and from -2 to 5, it changes by +7. Okay, so now we want to talk about how to write linear equations. And in general, when you're asked to write a linear equation, you can kind of assume that they mean that they want it in slope-intercept form. Okay, unless they specifically say some other form, slope-intercept form is probably what they're looking for. Okay, although that is an assumption, but that's what I would tend to do, and that's what the most common sort of form of a linear equation is that slope-intercept form. So when we are asked to write an equation for a line, I'm trying to put it in this y equals mx plus b format. Okay, slope-intercept form. And so the x and y are just the variables, okay? And m is the slope and b is the y-intercept. So if I look at what they give me here, I know that it has a slope of 3/4. Okay, it means it rises 3 and runs 4. Every time x changes by 4, the y value changes by 3. And it has a y-intercept of 4. Now, keep in mind, this is our b value. This actually represents the point 0, 4. Okay, so that's where it crosses the y-axis. So the question is, do I have m and b? Yes, they give me m is my slope and b is my y-intercept, and so I can just simply write this equation out. Y equals mx, so 3/4 x plus b, and my b value here is 4. And so there's my linear equation. Now, that's nice if they give it to you, but they don't always do that. Okay, so remember, we need these two things, y equals mx plus b. We need to find m and we need to find b. If they give us m and b, great. If they don't, we have to come up with some ways of finding those values. I'm going to skip that example. So let's say that I want to write the equation of this line. So here they give me a slope of -2, and it goes through the point 0.5. So the question is, do I have m and b? Well, I definitely have m, because they tell me that m is, right, the slope is -2, and that represents -2 over 1. Okay, that's a negative slope. It's going to go down from left to right. And they also give me this point 0.5. Now, if I'm clever enough, right, I know that the y-intercept, right, the y-intercept is where the x value is 0. So this is 0.5. This is where it crosses the x-axis or the y-axis. So they actually are giving it to me. They're giving me the b value, right? But they're just not explicitly saying that. So I do have m and I do have b. So I can write this equation, y equals -2x plus 5. Another example, write an equation for a line that has a slope of 3 and goes through the point 2.7. Now here's where it gets a little more tricky, because they give us a slope, so we do have m. Okay, we know that m is 3, but we don't have the y-intercept. Okay, they give us a point, but that point does not have 0 for x. And so this is not the y-intercept. And it's a very common mistake that people just take that second coordinate and use it for b, but that's not what we're doing. We're trying to find the value where x is 0, and we don't know what that is right now. So there's, again, a number of ways we could do this. One, I could just draw a graph. I could start at the point 2, 7, and rise 3 and run 1 and plot those points out and draw that line and figure out where it crosses the y-axis. That would be one way to do it. The second way would be to actually calculate this point. So if we look at this equation, y equals mx plus b, what information do we have in this equation? Well, we know the m, they gave us that. We don't know the b value, so we need to find that. But they do give us an x and a y. So they give us, they said when x is 2, y is 7. So what I can do is I can take these values and I can replace y and m and x, and then I can figure out what b is. So that's what I'm going to do. I'm going to put 7 in for y is equal to 3, which is the slope, times x, which is 2, plus b. And now I can go through and solve that for b. I can figure out what b is. So it tells me that 7 is equal to 6 plus b. And if I'm clever, I could say, well, 6 plus 1 is b is 7, so b has to be 1. Or I can, subtract 6 from both sides. And I can say 1 equals b. So I know that my b value is equal to 1. So I know my b value is equal to 1. And so I can write the equation in my line. Y equals 3x plus 1. Okay? Now, when we write this equation, right, remember we're writing a general equation for any x and y. So given any x, I can calculate y. So when we write our equation, we always want to have x and y in there. But to calculate b, we can use the values of x and y that they give us to help us calculate that b value. So there would be my answer. Here's another example. Write an equation for this line. Do we have m and b? Well, here they don't give us either one. I don't know what the slope of the line is, and I don't know where it crosses the y-axis. I don't have a 0 in one of my x coordinates, so I don't know where the b value is. But I can calculate these, right? I can calculate the slope. If I know 2 points, I can calculate the slope. And so I can see from this point to this point that it changes in the y values. It changes from 7 to 3. It's going down, right? It's decreasing by 4. In the x values, it's going from 1 to 5. That's increasing by 4. So my slope here is going to be -1, if I simplify that. Okay, so we're getting closer. We have the m value now, but we still don't have the b value. So we can go back to just what we did in the last example, and we can just use one of these points. We can use an x and a y value that they give us. It doesn't matter which one. I pick whichever one I think is most convenient. And for me, I'm going to use 1 and 7. Okay. So I'm going to plug these values in. I know that y equals mx plus b. So y equals m times x value is 1 in this case, plus b. And I don't know what b is. That's what I'm trying to find out. So I have 7 is equal to -1 plus b. And if I add 1 to both sides, I know that b has to be equal to 8. And so now I have my m, now I have my b, and I can write this equation. So y is equal to mx. Now, I've got a -1 here. When I multiply by 1, I usually don't write that. So this would be -1x plus b, and b is 8. So -x plus 8. Okay, so that's a slope of -1. Here I have another equation, right? Same sort of process. I don't know what m is, but let's calculate it. I see that m goes from 4 to -2. So from 4 to -2, it's going down by 6. And then from 3 to negative 1. From 3 to negative 1, it's going down by 4. It's going down by 4. Now, when I simplify this, I'm not going to get an integer. I'll get a fraction on this. So if I simplify this, negative divided by negative is positive, and then a 2, I can divide top and bottom here by 2, and I would get 3 over 2. And so that's my simplified form. So that's my slope, and a lot of times we'll have fractions of slope. Don't let that freak you out. It's just a number just like any other number, and we know how to deal with those. Now I need to calculate b, so I'm going to pick a point. I'm going to use this point just because it's positive and there's positive numbers, and like that just is more appealing to me. And so I'm going to say 4 is equal to m. So my m is 3/2. My x is 3 plus b. Okay, now I'm going to have to calculate here. I'm going to have to add and subtract some fractions, but we know how to do that, so we're not going to let that bother us. I've got 4. When I multiply fractions, I'm just going to multiply straight across. So if I think of 3 as 3 over 1, so 3 times 3 is 9, and 2 times 1 is 2, plus b. And then I'm going to subtract 9/2 from both sides. Minus 9 over 2. Minus 9 over 2. And so I have 4 minus 9/2 is equal to b. Now, here's where people will tend to get hung up. Okay, again, there's multiple ways to kind of think your way through this. If I think about 9/2, right? 9/2 is really, it's 4.5, right? If I write that as a mixed number, 9/2 is 4.5. So I have 4 minus 4.5. So I'm going to get negative 1/2 for my b value. Now, if you don't follow that, right, or if you have fractions that are more complicated than this, what you'd want to do is find a common denominator. So what I would do over here to find that common denominator, I would think about this, right, 4 as halves. So this would be 8/2, right? Multiply the top and bottom by 2, and then this is 9/2. And so when I have fractions, I'm just going to subtract the numerators here. So 8 minus 9 gives me negative 1, so I have negative 1/2. So my b value is negative 1/2. And so my b value is negative 1/2. Screen's freaking out there again. So, okay, and then I can write my equation. My equation is going to be y is equal to 3/2, my m value, x, plus negative 1/2, or minus 1/2. So there's the equation for my line. So I have a couple more examples here, but I'm going to leave these examples to you. I would take a look at these points, right, and see if you can figure out like what kind of line this is. You might think about what those points are. You might think about how much does the y value change here, right? I know that my y value here is not changing, so think about what that means. And then for this one here, again, if I go to look at my changes in my x and y values, my y value is changing by -6, but my x value is changing by 0. So think about what that means, and we can work these problems in class. Okay? All right, I'm going to go ahead and end the lesson here. Please let me know if you have any questions, and I hope you have a great day.